Look up at the night sky. On a clear evening, amidst the twinkling tapestry of stars, you might spot a reddish point of light. That's Mars, our celestial neighbor, beckoning us with its enigmatic allure. Since antiquity, humans have gazed at this red beacon, weaving tales of gods and wars, and dreaming of one day setting foot on its alien surface. Mars has captivated our imaginations for centuries, and today, our scientific curiosity continues to be fueled by the tantalizing possibility of discovering life beyond Earth and the ambition of one day making Mars our second home. Mars, easily visible to the naked eye, has been a source of wonder and speculation for millennia. Ancient civilizations observed its movements, attributing to it mythical significance. The Egyptians called it Horus the Red, while the Babylonians named it Nergal, their god of war. These early observations, driven by curiosity and a desire to understand the cosmos, laid the groundwork for centuries of scientific inquiry that continues to this day. As our telescopes improved, so did our understanding of Mars. No longer a mere point of light, Mars transformed into a world of its own, with discernible surface features and polar ice caps. We began to see Mars not just as a celestial object, but as a potential destination, a place where humanity might one day venture and perhaps even call home. The allure of Mars lies not just in its proximity, but also in its tantalizing resemblance to our own planet. While vastly different in many ways, Mars possesses familiar features like canyons, volcanoes, and polar ice caps. These similarities, along with the tantalizing possibility of past or present life, make Mars a compelling target for exploration and fuel our desire to understand this red planet and our place within the cosmos. Mars, named after the Roman god of war, is the fourth planet from the Sun in our solar system. It resides just beyond Earth, making it our next-door neighbor in the vast cosmic expanse. While relatively close in astronomical terms, Mars still lies millions of miles away, a distance that varies depending on the two planets' positions in their respective orbits. Compared to Earth, Mars is significantly smaller, with a diameter roughly half that of our planet. Think of it this way. If Earth were the size of a nickel, Mars would be about as big as a dime. This size difference translates to a weaker gravitational pull on Mars, meaning you'd weigh significantly less standing on its surface. Despite its smaller size, Mars boasts some impressive geographical features that dwarf those found on Earth. Take, for example, Olympus Mons, a massive shield volcano that rises 3 times higher than Mount Everest, the tallest mountain on Earth. Imagine the breathtaking view from its summit, overlooking a landscape unlike anything found on our home planet. While Mars and Earth share some similarities, they are also worlds apart in many ways. One of the most significant differences lies in their atmospheres. Mars possesses a very thin atmosphere, about 100 times thinner than Earth's, making it unable to support liquid water on its surface and posing significant challenges for human exploration. The first thing that strikes you about Mars is its striking red hue, a characteristic so prominent that it's earned the nickname the Red Planet. But what gives Mars its distinctive color? The answer lies in the abundance of iron oxide, more commonly known as rust, present on its surface. Imagine a rusty old car left to the elements for years. The iron in its body reacts with oxygen in the air, forming a reddish-brown coating we call rust. A similar process has occurred on Mars over billions of years. Iron-rich minerals on the Martian surface have been exposed to oxygen in the atmosphere, albeit a very thin one, leading to the formation of iron oxide. This rust has accumulated over eons, covering the Martian landscape in a fine, reddish dust that gives the planet its characteristic hue. The presence of iron oxide on Mars is not just a visual curiosity, it tells a story of the planet's past. The fact that iron oxidized on such a large scale suggests that Mars once had a more oxygen-rich atmosphere than it does today. This, in turn, hints at a potentially wetter and warmer past, a time when liquid water may have flowed on the surface, making Mars a much more hospitable place than the cold, arid desert we see today. The reddish dust that blankets Mars plays a significant role in shaping its environment. It gets whipped up by Martian winds, creating massive dust storms that can engulf the entire planet. These dust storms, some of the most intense in the solar system, are a testament to the dynamic nature of the Martian environment and serve as a stark reminder of the challenges of exploring this alien world. The rusty hue of Mars is more than just a superficial characteristic. It's a clue, a piece of the puzzle that helps us understand the planet's evolution and the processes that have shaped it over billions of years. As we continue to explore Mars, we uncover more about its past and its potential for harboring life.